Welcome back to another training video using the UK electrical simulator. In a previous video, we looked at the 2-plate and 3-plate methods of wiring two-way switching. In this two-part video series, we will take that circuit one step further by adding an intermediate switch between the two-way switches. An intermediate switch is a special type of switch used when we want to control the same light or group of lights from 3 or more locations. A common example would be a staircase or hallway arrangement. You may have one two-way switch at the bottom of the stairs, another two-way switch at the top of the stairs, and an intermediate switch on a landing in between. Any one of those switches can then be used to turn the same light on or off. The important point to understand is that the intermediate switch does not replace the two-way switches. Instead, it is fitted between them in the switching conductors. The two-way switches remain at each end of the circuit, and the intermediate switch sits in the middle. Its job is to change the path between the two strappers, allowing the circuit to be made or broken depending on the position of the other switches. In this first part, we will look at adding an intermediate switch to the 3-plate lighting method. Then, in the second part, we will look at the same principle using the 2-plate method, plus discuss an alternative 2-plate method known as wired through the switch. Let's start with the 3-plate method. First, we need to take the supply to the first ceiling rows. Connect a brown line conductor from L4 on the bus to loop L1 on the first ceiling rows. Then connect a neutral conductor from N4 to N2. And finally connect the CPC from E4 to the earth terminal. For now, we will not extend the conductors to the other lamps. We will get the first lamp working, then extend the circuit afterwards. Now let's wire the 3 switches. We have a two-way switch at each end of the switching arrangement, with an intermediate switch in the middle. First, double-click the intermediate switch to enable the extra backbox connector. In this example, we will use this connector to help bridge the 2 COM terminals between the two-way switches. Connect the COM terminal on the first two-way switch to the backbox connector on the intermediate switch. Then connect from that same connector to the COM terminal on the second two-way switch. These conductors are shown as black with brown sleeving, because they are being used as line switching conductors. Next, connect L1 on the first two-way switch to L3 on the intermediate switch. Then connect L2 on the first two-way switch to L4 on the intermediate switch. These are also line switching conductors. In the simulator, one is shown as brown and the other is shown as grey with brown sleeving. We have now connected the first two-way switch to the intermediate switch. Next, we need to connect the intermediate switch to the second two-way switch. Connect L1 on the intermediate switch to L1 on the second two-way switch. Then connect L2 to L2. And finally connect the CPC between the earth terminals of all 3 switches. The switching arrangement is now wired. The last task before we energize the circuit is to connect the switch arrangement back to the ceiling rows. Connect a permanent line conductor from loop L3 on the ceiling rows to L1 on the first two-way switch. Then connect a switched line from L2 on the first two-way switch back to SWL1 on the ceiling rows. Finally, connect the CPC between the earth terminal on the ceiling rows and the earth terminal on the first two-way switch. We can now energize C4 and follow the animated parts. The current flows through the first two-way switch, through the intermediate switch, through the second two-way switch, and then back through the switching arrangement before energizing the lamp. The principle is very similar to the standard two-way switching circuit. The main difference is that we now have an intermediate switch placed between the two-way switches. This gives us a third switching point. When the intermediate switch is operated, it changes the connection between the 2 strapper conductors. This either completes the path or breaks the path, depending on the positions of the two-way switches. You can add more than one intermediate switch if you need to control the same light from more than 3 locations. The two-way switches stay at each end of the circuit, and any additional intermediate switches are fitted between them. The final task for this video is to extend the lighting circuit to the other 2 lamps. We extend the neutral conductor, as normal, from the first ceiling rows to the second, and then from the second ceiling rows to the third. We also extend the CPC between each ceiling rows. However, because we want all 3 lamps to be controlled together, we extend the switched line not the permanent loop line to the other two lamps. So the switched line from the first rows is carried across to the switched line terminals on the second and third roses. This now allows all three lamps to be controlled from the three switch positions. I hope you enjoyed part 1 of this video series. In the next video, we'll use the 2-plate method and also the wired through the switch method and compare the two. Please like, subscribe and leave a comment below.